So we're going to start off section 9.5 by saying that to solve any quadratic equations, which is what we've been doing earlier in the chapter, we can first get that in the form m squared equals n. So that's anything squared equal to a constant on the other side. We learned earlier that all you'd have to do is take a square root and all of a sudden we'd have m by itself, and that way we wouldn't have to factor. So it's going to be helpful to get some of our more complicated questions into this form, and we're going to use the method called completing the square to do that. So let's say if I just put this in terms of just two terms for our polynomial. If I just had x squared represented by this big square plus 8x represented by these 8 bars, if I wanted to figure out how to come up with a third term here, I could do that by completing the square. So what that means is I could arrange these pieces along a side, so I have x squared and 4x on one side and 4x on the other, forming part of a square. And if I wanted to fill in those pieces, I could fill them in by adding 16 units to the end of my question. So that's 4 squared just to finish out the rest of this area. And that would give us this equation, x squared plus 8x now plus a 16. And we know from earlier in chapter 8 that this is actually a perfect square trinomial. Perfect square for the first term, perfect square for the last term. The middle term is twice the product of those two. And I can condense that down into x plus 4 squared. So again, we call that process in general completing the square. And a big piece of that process, and really a lot of our work here, is going to be coming up with this term. That was the 16 that we saw from earlier. If I put it into a formula, that's b over 2 and then that quantity squared. What we're going to be looking to do is look at the middle term. Again, that's the b term. Divide that in half and then square it. That's how I actually come up with the rest of that square. And this is going to work whether the b term is positive or negative, as we see in these next two examples. One b term negative, one b term positive. So let's try that first one. We want to come up with c just by following that formula that we found from before, b over 2 squared. So if I'm coming up with, again, b over 2 and trying to square that, all I got to do is find b from the actual function, so that's negative 16. If I plug in my b value, negative 16 over 2 and then squared, all I got to do is simplify this. So negative 16 divided in half is negative 8. And if I square negative 8, I'm going to be getting a positive 64. So that means if I wanted to make this a perfect square trinomial, I would write this as x squared minus 16x plus 64. And it doesn't ask us to do this, but the reason why we would add the 64, again, that's the only part of the question we had to answer, is because then I could simplify this down and get x minus 8 squared. If I tried the same thing on the other question, and hopefully you guys could try it yourselves as well, all I'm doing is following that same process. Look at that middle term, cut it in half, I get 10. Once I've done that, I square it, so I would just have 100. And similar to that last question, that means this x squared plus 20x plus 100 would now be a perfect square. And if I was trying to factor this down, I would just get x plus 10 squared. So a couple things are going to be important here. First of all, b over 2 squared. Again, that's what we're getting to finish our trinomial with in terms of where I'm getting that third term. But it's also important if I'm trying to factor this down is just remembering what was half of our middle term. If it was minus 8, we're going to see that in the factorization. If half the middle term was 10, we saw that in the factorization also. So that's what we're going to use when we end up trying to solve these types of equations. If I want to solve it, it seems kind of counterintuitive, but if I'm given a third term already, it might actually help to remove that third term, so subtract or add it, to get it to the other side and just look at the first two as we did in the last question. So if I want to do that on this type of question to solve, I would just start by subtracting 16. Remember, that's not usually how we'd start. We'd usually try this method, the x method. We plug in 16, negative 14, look for two numbers that work. But just to jump ahead of this question a little bit, we actually can't do that. We can't use factoring to solve it because there's no numbers that multiply to give you 16, but also add to give you negative 14. So it wouldn't even be solvable based on what we know so far. But if we're using completing the square, again, that first step was to remove that third term, because really it's our goal to come up with a better third term that's going to make that a perfect square. And we're going to do that by following the same steps. If I look at negative 14, remember that was our middle term, cut that in half. We're just following that same formula, b over 2 squared. Just the same as what we did on that last question. Again, we're trying to figure out what would go in that blank. So if I simplify this, negative 7 squared, again, should give me a positive 49. Reason why I left a little, again, space there is that we're coming up with that completing the square term. But what I've done to the left-hand side is not going to balance the equation unless I also do it to the right-hand side. So if I want to keep solving this, this is the equation that I've made, and we're just going to have to keep simplifying this down. So what we do know, kind of like those earlier questions, is that that left-hand side, that should be a perfect square trinomial. And similar to those last few questions, all we got to do is remember what was half of that middle term, because we're going to see that in the factorization. X minus 7 squared, if I multiplied it out using foiling, I would get back to this trinomial. So that's always going to factor down. Again, the reason why I do this is that's now a perfect square. So what I've done on the other side, though, is I took negative 16 and added 49 to it. That should give me a 33. It's going to be pretty fast to solve, going all the way back up to the top. We've got it in this form, perfect square on one side and a constant on the other. So just like our earlier sections, all I got to do to solve this is get rid of that square with a square root. I got to do it to both sides. So if I get x minus 7 just by itself on the left, now I have plus or minus a square root of 33 on the other. And last step is we just want to isolate for x. So let's add 7 to both sides. And now I get x is equal to 7 plus or minus that square root of 33. I'm going to work through the steps on the next one as well. Again, hopefully you guys could try that one yourselves. But just see if we can follow the same process. Again, we got to start by getting just the first two terms together. So I subtracted 15 on both sides. And then I did some work on this question. When it's odd, it's going to be a little bit harder. But half of that middle term is 9 over 2. If I square that, I get a fraction. So I had to add a fraction to both sides, kind of like we figured out how to add 49 to both sides. We know that simplifies down to a perfect square. Again, remembering that simplification from earlier, 9 over 2. And I did some work off to the side to see what would happen if I added these two and got fractions as an answer. Kind of like what we did on our first question, I got it to get rid of the second power by taking a square root. So once I did that, I subtracted 9 over 2 over to the other side. There's also a little bit of simplifying you can do with that square root. And this answer is a little bit more complex, but I just got that as a fraction. So again, the goal there is to get rid of that third term, come up with a third term yourself by following that same formula. And then once I plug that back in, it should be easier to solve as just taking a square root. So we can also use this in our graphing. If I make this function y equals x minus h quantity squared, notice that's a perfect square, kind of like what we have from our completing the square form. And then if I just add a third value to that, let's call it k, that's going to represent a parabola with a certain vertex at h and k. Kind of like how we had general formulas for lines, this is going to be a pretty common general formula for a parabola. You guys get more in depth of this kind of thing in Algebra 2, but we're just trying to figure out how to get this with a vertex. So I'm going to try to get into this form. It doesn't start with any perfect squares, but I'm going to try and find that by making our completing the square method work. So let's start this one the same way we did last time. I want to come up with a better third term. I say better because I want to make this a perfect square, and 8's not going to work. So first thing I'm going to do is subtract that 8 from both sides, and let's see if we can come up with a better third term that's going to make this a perfect square. We do that by following the same method as before. Negative 8 over 2, or sorry, not negative 8 over 2, our b term was 6, so that's 6 over 2 squared. Remember, that's always just half of that middle term and then square it. That should give me 3 squared, which I end up with as 9. So if I add 9 to both sides, didn't really leave a whole lot of room to add 9 on the other side. So if I add 9 to both sides, our left-hand side I can simplify as just y plus 1. And the whole reason we did this, the right-hand side, remember now is a perfect square using that same factorization we found from before. If it's half the middle term, it's going to factor that way as just half the middle term. So only one thing left to do if I want to get into this form is got to isolate for y again. So subtract 1 back over to the right-hand side. I get y equals x plus 3 quantity squared minus 1. And that's the equation of our parabola. And if we want to get the vertex, that means I'm just using, again, in this formula, it's also kind of weird because I'm using the opposite. So negative h means I'm using the opposite of 3. Negative 3 is my y coordinate. And then the k value is just that negative 1 from the end of the question. So that's negative 3, negative 1 as my vertex. Trying the same method on a couple other questions. Let's look at that middle one. Again, same thing. I got to get rid of that third term. We want to come up with that ourselves. Subtracted 10 from both sides. Then I followed my step. Half of 4 is 2. 2 squared is 4. Once I add that to both sides, now I have a perfect square. I just got to add the 6 back over to the right-hand side. And now if I take the opposite and then the y value, I get negative 2 and 6 for a vertex. Finishing with the last one, same kind of steps. I got to get rid of the 34 first because we want to come up with that third term. We do that by taking half of 12, that's 6. 6 squared is going to give us a 36. So following our formula, we add 36 to both sides. And remember that factorization is always going to work the same way. If I saw that half of 12 was 6, that's always going to factor as x plus 6, because again, that's just half of 12. And if I simplify that left-hand side, now I only got to subtract 2 back to the right, and using that same method, opposite of the x value, that's negative 6. Using that same value for the y value, I get negative 2 for my vertex.